As we finished up the lesson yesterday, we started to talk about comparing what we've covered so far this year: linear relationship, exponential relationships, and now the quadratic relationships in terms of tables and graphs. We all are familiar with a linear relationship, and we know that it's highlighted with a straight line on our graph. We can identify things. We know that the equation setup is going to be something in the term or in the form of y equals mx plus b, or y equals mx. We also identified that we knew that we had a constant change in x to our constant change in y. So this is going up 1 each time, and everybody identified that in class. And that we saw that the dependent, or the y growth, was 8.4 each time. So this was a constant rate. So when we did our discussion, we said that, hey, this goes 1 to 8.4, 1 to 8.4, 1 to 8.4, and so on, and it continues growing at that rate, which gave us a straight line. We understand that that's a linear relationship. We've covered this a number of times this year. The next thing that we talked about was an exponential relationship. And we know that it's highlighted on the graph because it starts to grow rapidly over time. In this case, we see that for each square, the term rubas, it grows. So each time this goes up 1 in our x, or our input, we see that the rubas grows from 1 to 2, to 2 to 4, to 4 to 8. So each time it is being multiplied by 2 the previous. So as we see this, so we know that because when we have a rate that is multiplying, we have a exponential relationship, which is represented with the equation that we've talked about earlier in the year, where we're going to have our input, or our output, is going to be based on our input as an exponential number, so that we can see that we have growth here that's going to grow greatly over time. And that finishes, and we finished up this lesson with talking about our quadratics. And when we got to quadratics, we talked about a situation in which we had our U-shaped graph, and we said it could either open downwards or open upwards. But in the examples we did, they were all opening downwards because we started at a low rate and got to a highest point and then started to come back down. And when we looked at this growth, as we saw it grow over time, we had a situation where at one point it might be 175. At the next point it might be 125. The next point after that it is 75. And then it worked its way and so on, so that we got to 25. But then we started to look at, is there a constant change between the values of our output at the second level? So the difference here is 50, and the difference here between 125 and 75 is 50. The difference between 75 and 25 is 50. And we stated, and we talked about the fact that when we see the consistent change in x, for a quadratic, we are going to see a change at the second level, not the very first level like we have been studying so far this year, but we're going to be looking at changes that is going to be a constant at the second level. So that helps us identify. We can look at a graph, or a table, a graph, or now we can start to analyze some of the data, and that's what we're going to be picking up in class here as we move forward.